You woke up this morning and didn't think about circles. You didn't marvel at the bearing in your desk chair, the tires that brought your coffee beans from Guatemala, the gears in the watch on your wrist, or the hard drive platter spinning in your laptop at 200 revolutions per minute. The wheel is so fundamental to civilization that we've made it a metaphor for futility. Why reinvent it? It's the first simple machine we teach children. Ancient, obvious, inevitable. Except it wasn't. ¿Por qué? The divergence point Mesopotamia, 3500 BCE. The potter's workshop in Uruk sits abandoned after a roof collapse kills its master craftsman and his 2 apprentices. They had been experimenting with a horizontal disc that could spin clay while shaping it, a technique that would have made pottery faster, more uniform, more beautiful. The innovation dies with them. No one else thinks to mount a circular platform on an axle. The cognitive leap that a rotating disc could multiply human effort never crystallizes. The idea doesn't spread because it never quite forms. Other potters continue shaping vessels by hand, coiling clay upward, perfectly adequate for their needs. 50 years later, a Sumerian merchant watches his workers drag a massive stone block on wooden rollers toward a construction site. He notices how the rollers beneath move in that strange circular way, how they have to be constantly repositioned from back to front. For a moment, something almost clicks in his mind. What if the roller could somehow stay attached, keep rolling, move forward continuously? The thought slips away. He's distracted by other concerns. The shipment is late. The wheel never happens, not in Mesopotamia, not in China, not in the Americas, not anywhere. The human mind, endlessly creative, simply solves problems differently. La Pruis Horian. Way out first adaptations, 3500-3000 BCE. What survives? Humanity doesn't collapse. Civilizations still rise along rivers. Agriculture still feeds cities. Stone still becomes bronze, becomes iron. Writing still captures speech. Mathematics still describes the world. The fundamental technologies of civilization, metallurgy, domestication, irrigation, construction, develop without needing rotation around a fixed axis. What changes? Transportation becomes an art of sliding, not rolling. The sled becomes humanity's supreme invention. Across every culture, master sled makers achieve the status of engineers. They understand friction like philosophers understand truth, intimately, painfully, through endless experimentation. In Mesopotamia, builders developed sophisticated wooden sledges with curved runners treated with animal fat and plant resins. The science of lubricants advances rapidly. Combinations of tallow, oil, beeswax, and later, mineral pitch. A good sled master can move astonishing loads across prepared paths. Roads evolve differently. Instead of ruts for wheels, civilizations build smooth stone causeways, polished by constant use, slightly concave to hold lubricant. The Romans, 2,000 years later, will perfect these glide roads with almost supernatural smoothness, using interlocking stones ground flat within a hair's breadth. Rivers and coasts become even more precious. Water travel, where friction nearly disappears, represents freedom from the tyranny of weight. Every civilization becomes a water civilization by necessity. Shipbuilding advances faster than in our world. Overland trade is expensive, slow, and limited to high-value goods. Cities huddle closer to waterways. The interior of continents remains wild longer. What disappears? The chariot never exists. Warfare will take an entirely different path. Lati Baal Automav, the cascade begins, 3000 BCE, 1700 CE, architecture without pulleys. The pyramids still rise, but differently. Without wheeled pulleys, Egyptian engineers perfect an elaborate system of parallel ramps, counterweights, and lever systems. Construction takes longer, decades longer, but succeeds through sheer human organization. The social structures required to coordinate thousands of workers without efficient mechanical advantage create more rigid hierarchies, more sophisticated planning systems. Gothic cathedrals developed different ambitions. Without block and tackle, lifting heavy stones to great heights becomes prohibitively difficult. European architecture grows outward more than upward. Buildings sprawl rather than soar. The aesthetic of the sublime expresses itself horizontally, in vast halls, in length, in networks of connected spaces. A different kind of beauty dominates. Military innovation. Without chariots, cavalry develops earlier and stranger. Mounted archers become supreme. But heavy cavalry, knights in armor, never quite emerge because moving that much weight across terrain without wheeled supply trains is nearly impossible. Warfare stays lighter, faster, more mobile. Armies remain smaller. The decisive pitched battle with heavy infantry and cavalry charges gives way to harassment, ambush, and siege. Siege warfare itself transforms. Without wheeled siege towers and catapults, attackers develop more sophisticated mining, chemical warfare, and infiltration. Defenders build different fortifications, not high walls to stop towers, but deep, complex barriers to prevent tunneling. Empires grow slower. Logistics limits everything. An army can only move as far as sleds and ships can supply it. Rome still unifies the Mediterranean. Water makes it possible. But expansion into northern Europe stalls earlier. Without wheeled carts, supplying legions beyond major rivers becomes impossible. Germania remains free. The shape of Europe refolds. Agriculture and settlement farming happens on a smaller scale. Without wheeled plows, farmers use lighter hand plows and animal-drawn sledge plows on prepared fields. Agriculture stays intensive rather than extensive. Deep cultivation of smaller plots rather than broad clearing of forests. Villages stay compact and numerous rather than consolidating into larger farming communities. The landscape remains more forested. Population grows slower. Mills still grind grain. Water power works fine without wheels. But wind power develops differently. Without the efficient rotation of windmill gears, engineers use reciprocating motions. Wind pushes a lever that pulls back through counterweight. It works, but captures less energy. Industrial power stays limited longer. The printing press Gutenberg's revelation comes, but modified. Instead of rotating cylindrical presses, early printing uses flatbed stamping, heavy plates dropping onto paper through lever action. It works. Books still spread. The Reformation still happens. But printing is slower. Books cost more. Literacy spreads more gradually. The information explosion that rewires Europe in our 1500s takes until the 1700s in this world. Timekeeping clocks develop through escapement mechanisms. Pendulums, balances, springs, none requiring wheels. Time still becomes measurable, portable, precise. Precision timekeeping enables navigation. The world still shrinks. But mechanical complexity stays limited. Without gear trains to multiply motion smoothly, clockwork never becomes a metaphor for the universe. The Enlightenment imagines reality differently, not as a mechanism of interlocking gears, but as a system of balanced forces. The philosophical implications ripple through science. The critical moment, 1750-1850 CE. The Industrial Revolution that wasn't steam power arrives on schedule. Observations of boiling water are universal. Metallurgy advances. Pressure vessels become possible, but the steam engine develops along radically different lines. In our world, James Watt perfected rotary motion, the crankshaft turning a wheel. Steam pressure became circular motion, became mechanical work, became the modern world. In this world, steam power remains linear. Pistons push and pull, but don't rotate. Early steam engines drive hammers for mining, pumps for water, presses for manufacturing. They're powerful, but stationary. Factories exist, but they look different, more like forges than mills, full of reciprocating stampers rather than spinning machines. Transportation faces an insurmountable problem. Without rotating axles, you cannot attach an engine to a vehicle. The very concept of a locomotive makes no sense. Steam-powered sledges are attempted, nightmarish contraptions that destroy themselves and the ground beneath them through sheer friction. Railways never happen. This is the crisis moment. The world stands at the threshold of industrialization, but lacks the fundamental mechanism to mobilize it. Factories can produce goods, but moving those goods remains medieval. Sledges, ships, pack animals. What emerges instead? Human ingenuity flows into canals like water finding its level. The 1800s see an explosion of canal building unprecedented in our history. Every industrializing nation pours resources into waterways, tunnels, aqueducts. Locks so sophisticated they're works of art. Steam-powered canal boats, essentially floating factories with linear engines driving paddle wheels, move goods at unprecedented speeds. The landscape of industrialization spiders along rivers and canals. Cities swell at water junctions. Coastal nations dominate trade completely. Britain's canal network becomes so dense that nearly every town of 5,000 or more has water access. Inland nations industrialize slower or not at all. Geography becomes destiny more than in our world. Railways never steal primacy from water. The canal age never ends. Personal transportation. Without bicycles, automobiles, or trains, most people still travel by foot or animal. Sled coaches exist for the wealthy, elaborate suspended carriages that slide on polished runners along specially maintained tracks. It's expensive, uncomfortable, and slow. Long-distance travel remains rare. Most people die within 50 miles of where they were born. The world stays larger. But the world today, present time. A day in the life, Portland, Oregon, 2026. Sarah wakes in her apartment 5 blocks from the Willamette Canal port. She can hear the deep horns of cargo boats being loaded for the morning departure to San Francisco Harbor. Her apartment building is 7 stories. Taller buildings exist, but without efficient elevators. Linear hydraulic lifts work, but are slow and expensive. Most people prefer lower floors. She dresses and walks to work. She's a data analyst for a shipping logistics company. Her commute takes 30 minutes on foot. She could take a sledge tram, the city's public rail sleds that run on polished granite tracks, powered by linear induction. But it's not much faster for short distances, and the morning walk helps her think. The tram glides past, nearly silent, its magnetic levitation keeping friction minimal. It's an elegant piece of engineering, but it costs 10 times per mile what a subway costs in our world. Only wealthy cities afford comprehensive tram networks. Most Americans still walk or ride horses. At work, Sarah analyzes canal traffic patterns. Climate change has disrupted water levels across the continent. The Great Lakes shipping corridor, once the industrial heartland's lifeline, faces frequent closures due to drought. Her company is routing more goods through the newly expanded Panama Canal system, but it's expensive and slow. Her computer runs on microprocessors that don't use rotating hard drives because they can't. All data storage is solid state, always has been. This drove earlier innovation in flash memory and crystal storage. Computing advanced differently, slower in some ways, faster in others. She eats lunch watching boats load. The container ship heading to Osaka can carry 5 Euro standard crates, massive by this world's standards, but a tenth of what our megaships carry. Global trade exists, but it's more expensive, slower, more precious. After work, she meets friends at a riverside bar. They talk about the election, the new desalination plant proposed for California, whether to vacation in the nearby coast or splurge on a canal boat trip to Vancouver. One friend mentions he's learning to code for quantum computers, the cutting edge of technology. Another is training for a marathon, planning to run the Portland to Seattle route along the I-5 Glide Trail. Without cars, distance running became more culturally significant, almost spiritual. They don't feel deprived. How could they miss what never existed? The broader world cities, dense, walkable, clustered around water. Sprawl exists, but looks different. Narrow development along canal networks rather than wide suburban spread. Downtowns remain vital because moving things long distances is hard. Environment, better in some ways, worse in others. Without cars, air pollution is lower, cities are quieter, but heavy dependence on water transport means river systems are more industrialized, more polluted, more controlled. Fewer wild rivers exist, society more local. Regional cultures stay distinct longer. National identity forms differently when traveling cross-country takes weeks and costs a year's salary for average workers. Technology advanced in surprising areas. Materials science progressed faster. The need to reduce friction drove innovation in lubricants, coatings, and surface engineering. Magnetic levitation developed earlier. Solid-state electronics evolved faster, but slower in others. Aerospace barely exists. Without wheeled landing gear, airplanes face enormous challenges. A few experimental aircraft have been built with sled landing systems, but they require perfectly smooth runways and remain impractical. Air travel is a fantasy. Space exploration never happened. Rockets work, but without wheels, the ground support equipment, the transport vehicles, the entire infrastructure required to build and launch spacecraft proved impossible to develop. Humanity remains earthbound. Medicine, comparable to our world. Medical knowledge advanced through different means, more focus on chemistry and biology, less on imaging technologies that require rotating gantries. CT and MRI machines developed later, using linear motion instead. Life expectancy is roughly similar. Globalization, slower, more expensive, more fragile. Supply chains exist, but are simpler, more regional. The just-in-time manufacturing of our world never emerged. Warehousing is huge. Buffering against delays is essential. International travel is rare enough that most people never leave their continent. Meeting someone from China or Kenya feels exotic, significant. The world is connected, but loosely. The reflection. What we learn about progress. In this world, humans still thrived, still built civilizations, still created art, science, philosophy, love, and meaning. The wheel wasn't necessary, it was just incredibly convenient. That convenience shaped everything: the speed of information, the scale of empires, the nature of warfare, the structure of cities, the psychology of distance. We live in a world built by rotation. Our cities sprawl because wheels made them possible. Our global economy exists because wheels made it profitable. Our assumption that progress means faster comes from technologies of acceleration. In a wheelless world, different values dominate. Locality, patience, connection to place. The journey mattering as much as the destination because journeys actually take time. Again, is this better or worse? The question feels wrong. It's different, more connected to water and land, less connected across oceans, more grounded in local community, less aware of global humanity. Slower but perhaps more sustainable. Smaller but perhaps more intimate. What we take for granted. You will leave this story and see circles everywhere. Doorknobs, bicycle wheels, the second hand sweeping across a clock face, rolling suitcases, spinning hard drives, desk chairs that swivel. You'll notice how much of your life depends on the simple fact that circles can rotate around a fixed point, a geometry so obvious that it feels like natural law rather than human invention. But it was invented, or rather discovered, and then applied. And if the people who first thought of it had died before sharing that thought, if the insight had simply not occurred, the human story would have unfolded just as richly, just as dramatically, along entirely different lines. We assume technologies are inevitable, that human ingenuity will always find the optimal solution. But history isn't optimization, it's accident and adaptation. It's one insight building on another, creating paths that feel inevitable only in retrospect. The wheel changed everything by making distance cheap. A world without it learned to love the places it stayed. The human cost and triumph. In this alternate present, a grandmother in rural Vietnam will never see Paris. The distance is too vast, the cost too great. In our world, she could, theoretically, save enough for a ticket. In theirs, the impossibility is absolute. But she knows her village with an intimacy we've lost. She knows every family, every tree, every bend in the canal. Her community provides meaning that in our world we seek across continents, never quite finding. A factory worker in Ohio doesn't commute an hour each way to a job that could be done remotely. The factory is local because it has to be. His life is slower, more constrained, but perhaps more coherent. A teenager in Nairobi will never watch a video uploaded by someone in Tokyo seconds after it was created. But the information she accesses feels more curated, more valuable, more carefully considered. The flood of content that drowns our attention never formed. These aren't better lives or worse lives. They're lives shaped by different constraints, finding different freedoms within different limits. Humanity remains endlessly adaptable. Remove any tool, even one as fundamental as the wheel, and we find other paths forward. Not the same path, not necessarily a better one, just a path. And on that path, people still fall in love, raise children, pursue dreams, question existence, create beauty, and find meaning in a world that seems, to them, perfectly normal and complete. They never knew what they were missing. Neither perhaps do we.